Hello everyone, my name is Shyamji and today I am going to solve the problem that is a 167 number problem on the lead code to some second. And the main constraint in this problem is the input array is sorted. So the problem statement is that you have given an array numbers and then target element and you need to find two index from the array so that the sum of the both two element at that given index will be the equal to the target element. So in this problem, the first target index will be lesser than the second the target index because you cannot use same element twice. So and another constraint is given in this problem that you are going to use one based indexing. So where you find an index which is sum is equal to the target, so you will return one based indexing. So let's try run a problem and think the approach. So you have given the array, first array is 2, 7, 11 and 15 and target element is 9. So if we take the first element is this and second element is this, then the array sum will be sub-array sum will be 2 and 7 will be 9 and it is equal to the target element. So I will return the index of this element is 0 and this element is 1. So for one based indexing, I will return 0 plus 1 and 1 plus 1. So this is my first index and this is my second index. So I will going to return this. So let's think what approach can I do here. So I have given the array 2, 7, 11 and 15 and we can take two elements at a time. So what if I make this subarray of two element and then find sum of that and check if it is equal to the target, then I will return the index of that. So if I make this first subarray that is 2 and 7 and second will be 2 and 11 and 2 and 15 and another subarray 7 and 11, 7 and 15 and another is 11 and 15. So I will check the sum of these two elements is equal to the target. Yes, then I will return the index of both for the one base index. So in this approach, I can directly write that I have given. I will like if I have given the array is this. So what if I take a pointer here and another is here? So first I am checking with this. I will fix it and move this pointer to the from I plus 1 to end. So first I will make pair of 2 and 7, then I will move this pointer to here and check the sum of 2 and 11, then move this pointer to here and check sum of 2 and 15, and now I will move the first pointer to the 7 and starting another loop is from 11 to 15. So here I am using two for loop and checking all the possible sum. So it will take order of n square time complexity and I'm not using any extra steps, so it will take order of 1 space complexity. So it is not be the good approach for this problem because Here I am using order of gen square time complexity. So what another approach I can see? So the problem in the problem statement, it is already mentioned that input array is sorted. So can I use two-pointer approach in this problem? Let's try. So I have given this 7, 11, and 15, and take first element from the start, and second element is from the end, and check if the sum is greater than the our target element. So like in this problem, sum of the 2 and 15 will be 17, and it is greater than target element. So I need to reduce the sum. So if you want to reduce the sum, so I need to go in the left direction and reduce our right pointer by 1, because our right pointer is pointing to the largest element. So if I reduce that, then I can find a sum that will be lesser than the previous. Like if the sum of the 2 and 15 is 17, so if I reduce this right pointer from here to here, so I will find another sum that will be 13, and it is lesser than the previous sum, that is 17. So this approach I'm going to use in this problem, and our 13 is also greater than 9. So I will again reduce the target right pointer. So it points to the 7. So if I take sum of 2 and 7, it will be 9, and it is equal to the our target element. So I will return the index of this. So our another test cases 2, 3, and 4. 2, 3, and 4. So I keep this pointer to here and check this sum. So the sum of 2 and 4 is equal to 6, and our target element is 7. So it is less than the target element. So I need to increase our sum. So if I move the left pointer to another element like here, so I will found the any sum that is greater than the previous sum, because we are increasing the left pointer and it is going to the greater element. So if I increase the left pointer, then I can find array, another sum that can be equal to the target element. So this approach I'm going to use here, and if I take another subarray, that will be like 2, 3, 4, 9, 11, 13, and the target array element is 13. So start with this approach. So if I take a pointer here and another pointer is at the end of the array. So first find the sum of first and last. So it will be 15, and it is greater than the our target element. So I need to reduce our sum. So I will move the right pointer and decrease it by 1. So it will point to the 11. And now I will find this sum of both two elements. So it will be 11 and 2. So for this 11 and 2 is 13, and our target sum is also 13. So I can return, because in this case I have two pairs whose sum is equal to the target element. So I can return anything in this, because our both answer is valid because here is no any constant which means some that you need to return the first pair or second pair. I can return anything. So I can use this approach. So let's write the code for it. So if I take a for loop, start from first I will take a pointer that is our int left that is pointing to the starting, and another pointer is right pointer that is initially pointing to the array dot length -1 at the end, and check while because I cannot use the same element twice, so I will check if that left index is lesser than right element, so I will check, and if it is equal or crosses, so I cannot use because there is already mentioned in the problem that your first index will be lesser than the second index. So I will find the sum of this. So if our sum of both element is array of left plus array of right, and check if sum is equal to the target, so I will return because I have found the index, so I will return the that index. So then and the first index will be left, right. But in this problem, it is mentioned that you need to return the one based indexing. So I'm using the zero based indexing. So I will add one to it. So it will be our one based indexing. And if it is not equal to this, because the cells, I will check if sum is less than the target. So I need to increase our sum. So if I move the left pointer to be in the right side, so our sum will be increased, so it will be left equal to left plus 1 and means if it is sum is greater than the target element, so I need to reduce this sum, so I will move right pointer to the left because in the left side there is a smaller element to the current element, so I can reduce it. So right will be right -1. So this will be my code. And if I not found any indexes, so sum is equal to the target element, so I will return anything like if I'm using zero based indexing, so I can also return the 0 comma 0 because I'm using one based indexing in this problem, so 0 will be not my valid, 0 will not be my valid index, so I can just return it. So how much time complexity it will be take? So here I am using a left pointer, a right pointer, and how much left pointer can I move? Because if the target array is like 2, 7, 11, and 15, and if our left pointer reached here and right pointer is here, and when it will cross one another, so How much? Because in one step, either I can move our left pointer or I can do move our right pointer. So in the first step, I am moving our left pointer is here, and then I move it here, so it will in the two steps, and our right pointer is here, and then I will move it to the here. So it will take approximate four steps. So I can say that our time complexity will be order of n, because when left pointer crosses the right pointer, then I will end this loop. So I'm not repeating any element. Both I'm not repeating both index again. So our time complexity will be order of n and the space complexity will be order of 1, because here I'm not using any extra space. So this will be my code and will be the complexity of this approach. So this is the problem, and in the previous cases I have tried run it for the more than one solution, but it is already mentioned in the problem. So you have given you have exactly one solution of the problem, and may not use the same element twice. So this code is also work for this approach, because there is exactly one solution, so I can find it. So this is my answer, and this is the code. Thank you.